Hi y'all, let's do a couple examples with the central limit theorem with the same example we worked with in the previous example videos. So for this first question, find the probability a sample of size 15 has a mean greater than $43,500. So how do we know that this is a central limit theorem problem? Well, the answer to that is that the thing they are asking for is the probability of a sample mean. So anytime it says the mean of the sample or the sample mean, that's going to be a central limit theorem problem. So we are going to start with the probability that the sample mean is greater than 43.5. So let's write that out. So the probability that x bar, which is the sample mean, is greater than 43.5, which is equivalent to 43,500. So we know we have to convert this x bar to z using these formulas. So let's just go ahead and do that. So we have the probability, and then x bar, so this is going to be z over here. So z equals, just copy this, x bar minus mu sub x bar over sigma sub x bar. And then is greater than, in our x bar is going to be 43.5, sorry, minus our mu sub x bar is 40, and divided by our sigma sub x bar. So let's just do that over to the side here. So sigma sub x bar, sorry, my sigmas tend to look like sixes, but equals, and it's sigma, right? So sigma is 5 in this circumstance. 5 divided by square root of our sample size. So our sample size is 15. So if we plug this into the calculator, we will get sigma sub x bar is 1.291. So we now put this in 1.291. Okay. So that equals the probability of z being greater than, if we put this all in the calculator, we get 2.71. And now we get this from the table, we find 2.71, the z, but we say this is greater than, and the table has the left side, so, and this is the right side. So we know that we should be getting used to this, that we do 1 minus what we find in the table for 2.71. So let's go to the positive side, 2.71, and that's 0.9966. Oops, sorry. So we have 0.9966, and doing that in the calculator, we get equals 0. Sorry, pen is missing. 0.0034. So if they ask you would this be unusual? Um, the answer would be yes, because it's less than 0.05, which remember if that rare event rule, so it would be unusual to have um, with a sample of size 15, to have a mean greater than $43,500. Okay, for the second example, what proportion or percentage of samples of size 40 would have a mean between 39,000 and 41,000? So now we have a different sample size. That means our sigma sub x bar is different. So we have to calculate that. So sigma x bar is now going to be, we have the same sigma, which is 5, but our sample size is 40, so square root 40, which gives us, if we put this in the calculator, we get 0.7906. So now, what's the proportion or the probability that the sample mean, like I said, is between 39,000 and 41,000. So that is probability 39 less than x bar less than 41. So that's going to equal, converting the x bars to x's like we always do using this formula, we have 39 minus the mu sub x bar, which is 40, divided by the sigma x bar sub x bar that we just got, so 0.7906 is less than z, which is x bar minus mu sub x bar over sigma. Less than, and then on this side it's just 41 minus 40, that's mu sub x bar, over our sigma sub x bar, which we just got. So plugging these all in the calculator, we're going to have probability that it's negative 1.265 is less than the, and then on the same side it's just going to be symmetric. So we go to the standard normal table, or the normal distribution table, and we have the middle part. So if we remember, let's draw this over here. We now have, this is lovely. So our two z's are right here. So if we remember, we have to find the probability on the z-plot first, this side, this whole thing, minus this area. So what we have to find is the probability that z is less than 1.26 sorry, 10 is kind of goofy, minus the probability that z is less than negative 1.26. Okay, so go into the table. Let's look for 1.265. One, two, three, 4, 5, 6. So 0.8962. Move this screen over for a little bit. Okay. My pen. Okay. So 0.8962 minus, and then the negative side. What do we do? Okay. Negative 1.26. 1, 2, 3, 4, 5, 6. So it's 0.1038. On the screen. Okay, so it's 0.1038. So that gives us a probability of 0.7924. So that's our answer. And those are our two central limit theorem problems.